Lesson 10-2, simplifying radical expressions. Our objective today is to simplify radical expressions and also variable expressions. These are Algebra 1 standards 1-2, 6-3, 8-3, and 8-8. A radical expression is an expression containing a radical sign. That symbol is a radical sign. Most people call it a square root sign. Well, basically it performs the operation of square root, but it really, honest and truly, is called a radical sign. What is inside of it is known as the radicand, and I'm just giving you some vocabulary words just so that you are educated with those. So a radical that performs the operation of square rooting, and inside it is a radicand. Square rooting is saying what value multiplied by itself would give me this radicand amount. So we're looking at lists of perfect squares to kind of get this started. So 1 squared is 1. And then on the flip side of that, if you perform square rooting of 1, you'll come back to the whole number of 1. That one's kind of boring. So 2 squared is 4, and you do radical 4, you get 2. So a perfect square is a number when you take the square root of it, it gives you a whole number. Okay, so there's only so many of those, and it's important that you know those. All right, I believe on the I-STEP you discovered that you were supposed to know some of those without using calculators and all that, so you could do estimation of square roots. Okay, so you should be able to continue that list, 1, 4, 9, and so on, 16, 25, 36. You should be able to continue that list and know when you square root those, you get a whole number. Okay. To be simplified, this is very important. It means that there is no perfect square as a factor of a radicand. Okay, to be completely simplified means there's no number left in the radical sign that is a perfect square. So let's see what we're talking about here. You're going to do this, and more than likely a calculator is not going to help you very much at all. Okay, your knowledge of perfect squares needs to be pretty good, and I think it is for most of you, that you know the perfect squares and how you can kind of simplify them out of different values. So let's look at the first example, and you'll see what we're talking about here. Radical 128. So in the radical of 128, I can take that amount and I recognize that there is a perfect square of 64 that is a factor. So I'm going to separate that to 64 times 2. Now you're better off if you can find the largest perfect square that's a factor of the radicand. If you don't, well, then just look and see what's left and see if there's any more factors in there. What happens when you got the square root of 64 times 2 would be this. It splits apart. Square root of 64 times the square root of 2. What is the square root of 64? 8. So you would say 8 radical 2. And that would be the simplified value for radical 128. Olivia.
So you just find the square root of 128.
We are simplifying the square root of 128. You're trying to take out every perfect square that you possibly can take out of there. And then in the value of 2, there's no perfect square in it, so there's nothing else to take out. What's left in the radical is going to be numbers that are not perfect squares or have no factors that are perfect squares, and that's called a simplified value then. Okay, Ethan?
Would it be any different if you would have used some different perfect square than 64 to equal 128?
No, because you would keep going until you got to this one. You're never done until the number inside the radical is as low as it can go. Okay? Yes?
How would it have worked or looked if you used perfect square of 121?
If you use the square root of 121, then it would just be 11, right? If it's a perfect square, then you just change it to an integer.
I'm just saying, like, for the 128, like, if you, instead of using 64, we use 121.
121 is not a factor of 128. You could have taken out 4. So let's say we did that. Let's say we did 4, and it would be 32. Okay? Well, that's all well and good. It's square root of 4 times the square root of 32, which is 2 radical 32. But you know what? Radical 32 is not done, because in radical 32, I've got a 16 times a 2, don't I? And then it would be 2 times radical 16 times radical 2, which would be 2 times 8 times radical 2. Oh, nope, 4. Sorry, mess up there. Which would be 8 radical 2. You're going to get the same answer because it's the same value. It's the same number. It's not going to become anything else. There's only so many factors that are perfect squares that would be in your numbers. And whether you use the biggest one or the smallest one, the number inside the radical has to be completely reduced so that there's no more perfect squares inside of it. So let's do radical 52. There's only one perfect square that goes into 52, and that would be 4 times 13. And then therefore you split that apart, square root of 4 times square root of 13. And you know the square root of 4, so 2 radical 13. That is the simplified answer as low as you can go. Ben?
Can I do C?
Sure. What are you going to do with radical 18, Ben?
So we're going to make radical 18 equal to radical 9 times 2.
Okay. So break that apart. Radical 9 times radical 2, and my final answer would be?
Oh, it would be 3 radical 2.
3 radical 2. So you're pulling out perfect squares, as many as you can, or as many that exist. What's left in the radical sign is something that has no more factors that are perfect squares. All right, questions about that? Okay, so now let's look at something different. They might give you a problem like this, and we're learning radical rules. So one thing that we learned up here is that if you have a product, so I'm talking about this right here, if you have a product in a radical sign, it can be split apart to 2 different radicals. Those 2 things are equivalent, okay? So on the flip side, we have this right here. If I have a radical times a radical, then that is equivalent to a radical with a product inside of it. So it's just the opposite of what we just did. So what's going to happen here then is this. Radical 2 times radical 24 would be radical 48. That is not a simplified good answer. And every time you answer with the radical, it is a given that you simplify out all perfect squares. Just like you have learned, it is a given with the fraction, you automatically must reduce it, right? That's just a given. Well, with these, it's just a given that you don't leave a perfect square in there. It's just a given. So this then would be 16 times 3. And you will get to the point, hopefully, that you'll just recognize the biggest perfect square you can pull out of there. So 48 is 16 times 3. So you would say radical 16 times radical 3, and therefore 4 radical 3. The further you go on with this, honestly, you won't have to write all those steps, but today I think you should. Okay? Hopefully the more practice you get, you recognize that, oh, that's 16 times 3. Okay, you bring the 16 out as a 4, 4 radical 3. You wouldn't have to go through all those steps. Okay, questions about that? We're going to practice this a little bit more, and I'm going to show you a little bit more and more properties with it. Okay, so now I've got a little bit more to it. I've got a number out of the radical times a number in a radical, and then multiplying it by another number just like that. So in this case, you would do this. You would take the numbers outside, the 3 and the 2, and multiply those, so 6. And then the numbers inside, the 8 and the 7, and multiply those, but they have to remain inside, so 56. Okay, 56 is not done because it has a factor of 4. So it's 6, and then in the radical would be 4 times 14, which would be 6 times radical 4 times radical 14, which would be 6 times 2 times radical 14, so 12 radical 14. And that is your simplified answer because 14 has no factor that's a perfect square. Questions about what I just did? Okay, 3 radical 6 times 8 radical 8. So again, the numbers on the outside, 3 times 8 is 24. Radical, the numbers on the inside, 6 times 8 is 48. Hopefully you recognize from 48 that breaks apart to 16 times 3, which would be 24 times radical 16 times radical 3. So in other words, 24 times 4 times radical 3, and then end up with 96 radical 3. What do you think about that? If you like that, you're really going to like this one. Questions about either of those two before I move on? Okay, 4 radical 2 times 5 radical 8. So again, multiply the numbers on the outside. 4 times 5 would be 20 times, and then 2 times 8 would be under the radicals, so 16. Oh, looky there. Perfect square, huh? So 20 times 4, it would be 80. What do you think about that?